Hi, I'm Bill Armstrong with Fluid Handling, and what we're going to talk about today's video is how to determine the flow from a pump using the pump curve for that pump and pressure gauge. And this is something you'd have to do in the field, system startup, or to analyze system problems perhaps. Let me just go through our pump test setup so that that's clear to start out. We have a Taco 1911 inline pump here. We're pumping around a loop, and the first thing we come to is a flow meter. Now, you wouldn't normally have this on a project. The flow meter is to help us determine how accurately we can predict the flow using the pressure gauge. We have a piping loop that comes across here, and we have a valve here. And this valve we can open and close to simulate different pressure differentials across a given system. And I've got that set at a certain point today. I don't know where it's set exactly. That's what we're going to try to determine from our test. We have a sump, so we've got an open system. We're pumping into and out of that plastic sump. So back to the pump. This is a little bit noisy, and the reason it is we've put a DC drive on it. The reason for the DC drive is when we do experiments to determine pumping power, it's much easier to predict or to do the calculations using direct current. But that's not a normal situation, it's just for our pump setup. And it's a variable speed drive, so I can change the speed to anything I want. We're going to run at 1750 today, which is the normal pump speed, and that's the speed at which the pump curve is published. So the first thing I'm going to do is turn on the drive, turn on the pump, let it come up to speed, and I'll adjust it to as close as I can to 1750 RPM. And it looks like I'm just about there. I kind of preset this. So to determine the flow from a pump, I need to know the differential head that the pump is developing. And this pump is properly set up with a single gauge. This gauge has two valves. One valve lets us read the discharge pressure of the pump. The other valve allows us to read the suction pressure of the pump. Now, you could do this with two gauges, but by using one, I eliminate any errors that might happen if I use two gauges that were off calibration in different directions. So let's take the discharge pressure reading to start out. I open this valve, and I can see that I've got a discharge pressure of right about 6.3 psig. I'm going to write that down on a whiteboard. .3. Now, let's take a suction reading, and close off the discharge valve, open the suction valve to the gauge, and it'll take 10 seconds or so to settle out. Now, I'm reading a negative value here. I'm reading in inches of mercury. Often you will read a positive value, but in this particular setup I've got a negative value, and it's kind of still bouncing around a little bit. Let's call it 4 inches of mercury. Now we have to do a little math. Pump curves are always based on feet of head, not psig and not inches of mercury. So the conversion factor from psig is to multiply psig times 2.31, and that will give us feet of head. So 2.31 times 6.3 psig, we've got a discharge pressure of 14.6 feet roughly. That's rounded off a little bit. 14.6 feet. Now on the suction side, when we convert inches of mercury to feet, the multiplier is 1.13. So we've got 4 inches of mercury on the suction side times 1.13. That's 1.13 times 4.5, so that's 4.5 feet. Now, I can determine my total differential pressure. I'm going to subtract the suction pressure from the discharge pressure. Now because I'm starting with a negative, I'm subtracting a negative number, so that's going to be a positive. So I can see that 14.6 plus 4.5 is 19.1 feet of differential. Now using that measured differential and the pump curve, I should be able to predict the flow. So at this point, we're going to stop, we're going to plot this value on the pump curve, and we're going to predict our flow. All right, this is a pump curve for the pump on the test stand, a Taco 1911 pump. We know from the nameplate that it's got a 4.75 inch impeller. These are different impeller diameters that could be installed, but we've got the 4.75. If I plot my 19 feet of differential, come across to that 4.75 inch impeller curve and drop down, you can see we're predicting, oh, maybe just a hair over 42 gallons a minute. So the next thing we're going to do is go to the flow meter and see how we did. So we've plotted our values on the pump curve. We've predicted a flow of 42 gallons a minute. Let's look at the flow meter. You can see that we're right between 40 and 45, maybe a little closer to 43. As you can see, we've come very close to the number that we predicted by using the gauges and the pump curve. There are many times you may find yourself in the field wanting to know what the flow is from a pump and not having a flow meter like we have here. I think we've shown that using a good quality gauge and pump curve, we can come pretty darn close to determining what the pump flow actually is. Thank you.